Thank you, Ned, for the earlier introduction, and thanks to those of you that came to our demos and our poster yesterday. We were in the cafeteria far away from the bar, so I know a lot of you didn't make it that far, but it was good to interact with some of you and show some of the cool stuff that we're doing. We're a line-funded project. We're a relatively large line-funded project. Most of the team is sitting all the way in that corner, which you can tell they're developers because they're hiding all the way in the back. But the idea behind EdgeEnabled tactical systems, what we do is provide capabilities to people that are operating at the edge. When we talk about edge, what we're really talking about are these environments that are very dynamic. They're dynamic in context, they're dynamic in missions. You have very limited connectivity. People are potentially have high levels of stress. So what we try to do is deliver those mobile systems so that really people can do their job better. So some of the things that we focus on are improving situational awareness, on reducing cognitive load, on increasing computing power, and on reducing the human operator to sensor ratio. So the colors did something very weird. Those are not the colors I would have chosen. Definitely not. They know it's true. So we divided our work into 4 focus areas. The first focus area is group autonomy for mobile systems, and I'm going to ask James Edmondson to wave. Wave, James. James is the lead for that particular task, or GAMS, and the goal of that focus area is to reduce that human operator to sensor ratio, especially when you have autonomous platforms collaborating or coordinating. The second focus area is ICE, or information superiority to the edge. Wave, Jeff. Jeff is the lead for that particular focus area, and what that really focuses on is exploiting or leveraging group context so that the right information is shown to the right person at the right time. The third one that you can't see for some reason is called Edge Analytics. And what Edge Analytics really focuses on is on building architectures that can process a large amounts of streaming data at the edge, not at the big data center, but closer to the edge. And finally, Tactical Cloudlets is our work that we do in collaboration with Satya. And I'm going to ask Satya to wave because he was here. Satya is our collaborator on campus for that particular task. And what we're trying to do is build little data centers in a box. Some of you had a chance to see those yesterday. So let me go in a little bit of detail in each of the focus areas. So GAMS, the one-liner behind GAMS is enabling scalable, heterogeneous, collaborative autonomy. So as you know, the autonomy paradigm is shifting. It's not no individual platforms that are being put out there, but larger swarms or platforms that are being put together and have to coordinate in real time. So this brings with it several challenges. The first challenge is obviously scale. The second is portability, because a lot of these platforms are very heterogeneous. The third is now having them communicate effectively, even though they're in an intermittent, limited time of environment from a communications connectivity perspective. And more generally, is the challenge is how do we make these types of systems easier to develop, easier to program? So what GAMS has been focusing on for FY14 is on designing middleware and tools that enable this autonomous collaborative behavior. So specific results in FY14 are that the team implemented several algorithms that represent behavior that is expected of collaborating autonomous platforms. The first, several algorithms for scalable formation flying with mission context, several algorithms for prioritized area coverage, and these algorithms were implemented, and then they were simulated in several VREP simulations that scaled the amount of platforms and things like that. And so we were visually able to validate that indeed the behavior that was expected was indeed seen. As far as real live implementation, these algorithms have been integrated into CMU's DroneRK, quadcopter system, and also with the Platypus autonomous boats that are Anthony Rowe, correct, James? Paul Sherry, sorry, wrong scientist. Paul Sherry. With the DroneRK, there have been some problems because some of the algorithms rely heavily on a function called move to GPS, and it's not precise enough to get a real understanding of how they behave. However, the integration and testing for the autonomous boats is scheduled for January. There have been several presentations as well as a paper published specifically on the education part, how to make it more easier for people to develop these kinds of systems. For information superiority to the edge, as I said before, the goal is to leverage group context. So I'm not only leveraging the context of the individual person, but I'm leveraging the context of the complete group that that person was deployed in. Why? Because, as we like to say, the whole is greater than the parts. So there have been several things that we have done with EETS in this part. First of all, we've extended the context model. Typical context-aware systems rely basically on location and time, and they define that as context. And lots of you use context-aware applications every day. We've extended it to include context that is important to a group, like, for example, the role that they're playing inside a mission or the task that they're executing. And specifically in FY14, there are some very interesting results. So the people at the bottom left are people from the 911th Airlift Wing out of Pittsburgh. And what we did was we conducted a team experiment with them. They are playing paintball. And people, when they're playing paintball, they get very competitive and aggressive. So what we were able to do was we strapped them with a smartphone on their chest and several like high, very precise, very fine-grained accelerometers. And we scripted some scenarios that they needed to execute. Because what we were trying to detect was activity recognition. By the data that is being gathered by the accelerometers, are we able to detect not only what they're doing as an individual, but also what they're doing as a group? And so far, the data is currently being processing. It's a lot of data, because what we did is that, obviously we gathered the data, but we also took video, because we want to be able to compare. Is what the data showing really the same as what the video is showing? And they were synchronized. And so far, and this is work done in collaboration with an INDE, I should have said that, also from campus. And what he has shown, is showing about a 90% correlation or effectiveness, which he says is pretty good. It's pretty good or pretty normal in this field of activity recognition. So that's one of the things that team has been able to do. Also, as Jeff mentioned earlier, into the platform, we were able to integrate with DTN. It was very easy to integrate. Our group has a strong development focus, but we also have a strong architecture focus. We really believe in architecture. And the reason that we have a very flexible architecture that enables us to easily integrate DTN as an additional communication mechanism. The screen on the right is from a Benghazi scenario prototype and demonstration that we did. This was a pilot study where what we were trying to do was, is it possible to integrate the ICE capabilities, which is what I'm talking about now, with the edge analytics capabilities that we'll talk about later? And what this is showing is a particular, what we did was we gathered data from the Benghazi scenario, the attack on the embassy. And what we were able to do was, can ICE not only use group context, but can it also use data streams coming, for example, from a command center that is processing these edge analytic data in order to make even better decisions and inform personnel of what they should be doing in case of an attack, for example, on the embassy. This work has also the ICE architecture, again, very strong focus on ICE architecture. Two of our team members, Jeff Bowling and Mark Nowakowski, have been very active in the TALIS project. The TALIS is the tactical, A means something, L means light, but it's basically the Iron Man suit. Assault, thank you. It's basically, I am acronym impaired. It's the Iron Man suit. So these two fellows are part of the computing team, and the ICE architecture is being used as the reference architecture for integrating all the data that is being generated and consumed by this suit. I think it doesn't like green, because I think Edge Analytics was green. Anyway, but Edge Analytics, so out of the 4 projects, this is probably the one that we've received the most interest in and most attention for tasks. What Edge Analytics focuses on is on building architectures that are capable of rapidly processing streams of data. So just as a caveat, what we have been using as our test data is Twitter data. Why? Because it's readily available, because it has an API, because it's easy to use, because people understand Twitter. Well, not everybody tweets, but most people understand what Twitter is. But the key behind this particular task is, Paul, you don't tweet? I tweet. Okay, there you go. A lot of people don't. But you understand what Twitter is. But anyway, so the idea really is the architecture, is that we have built an architecture that is really capable of processing lots of different types of streams. And the goal is to bring those analytics that are typical in the data center, to bring them closer to the edge. And so what are some of the things that we have done in order to be able to provide this data analysis capability at the edge? The first is timeliness, fidelity trade-offs. What that means is, maybe I can't give you 100% answer, because that's what you can do back in the data center. But I might be able to give you an 80% answer. That might be just what you need right now. But I can give it to you in a second or 2 seconds, as opposed to having to wait for days or whatever it is, hours to be processed in the data center. Maximizing resource utilization elasticity. The architecture is extremely, extremely scalable. It's very modular. It scales to whatever resources you give it. You can give it a cloudlet, or you can give it a big data center, and it will scale. We're also leveraging contextual clues from the hyperlocal edge environment. So hyperlocal is one of those current words, and it almost means beyond local. So for example, hyperlocal would mean I, as a user, know that I'm at the Wyndham right now, as opposed to saying I'm in Pittsburgh, or as opposed to saying I'm in Oakland. So hyperlocal is being able to leverage cues from the user, so that, for example, when I'm streaming a large amount of data, I can say, you know what, I don't care about data that is not from like Oakland. So don't process that data, and dedicate your cycles to processing the data of interest to me. And giving the users that particular capability. So for those of you that saw the demo yesterday, these were some of the things that we were using. These are just some examples of some of the analytics that we can do. But like, these are Twitter related, but like I said, it's very easily to plug in new analytics as well. That's another thing that's good about the modular architecture. And those are some of the characteristics of the architecture. It's event-based, it's fault-tolerant, it's a microservices-based layered architecture. It's very pluggable, so some of the analyses that are there, what's on the, actually I can see it, yeah, it shows well. So what is on the top right is a streaming graph analysis. So it's basically saying, of all the tweets that I'm getting, who are the people that are being tweeted about? And there's a legend for this, but the colors mean something the size as well of each one of the circles. The one on the right below that is a trending named entities. So of all the tweets that I'm receiving related to a particular event, for example, the demo yesterday was pointing at ISIS data. Of all the events related to ISIS in this case, what are the named entities? What are the organizations that people are talking about? What are the people that people are talking about? And each one of those colors means something different. Then total sentiment analysis is the one in the middle. So of the tweets that are being tweeted, what percentage are happy tweets and what percentage are sad tweets? So it's sentiment analysis. And finally, location inference, which is based on the tweets, can I tell what areas or what parts of the world are being tweeted about? And finally, tactical cloudlets. As I said, this is work that we do in collaboration with Satya and his team on campus. The idea is really to move the cloud computing capabilities that are available in the big data centers to move them closer to the edge. So those of you, again, that went to the demo yesterday saw that we were running a cloudlet on a what I call a plain vanilla laptop. And the idea is that these cloudlets they're forward deployed, they're discoverable, so that people that are near them can use them not only for computation offload, but also for data staging. And what we focused on in particular for FY14 was trying to prove that the use of these cloudlets, tactical cloudlets, increases the survivability of mobile systems. So what we did for that was that we studied what survivability meant from an academic perspective, and then we use our SSD colleagues to confirm if what we had discovered matches what they see in their work with our stakeholders. And so what we were able to say is, let's look at survivability. So first of all, let's look at the threats, because we agree with one of the work that we looked at that said you can't talk about survivability if you don't understand what the threats are. And then what we tried to do was map those to characteristics of the environment. So what are the threats? Not that we're ignoring the cybersecurity threats, the cyber threats, but what are the threats that are coming from the environment itself because of the fact that these are deployed in edge environments? And we mapped those to system requirements. And what we did was we added features to our tactical cloud implementation in order to map to those requirements to see and experimentally validate that they were indeed, at least according to our definition of survivability, they were increasing survivability. So one of the things that we did was that we experimented using several cloudlet provisioning mechanisms, and the one that we finally decided on was a combination of pre-provisioned cloudlets with App Store. So now, when cloudlets are pre-provisioned, you not only pre-provision them with the functionality, the capabilities, but you also provision them with the app that the people in the field would have to use in order to use the cloudlet. So we're combining the two big, typical cloud computing capabilities, which is pre-provisioning and App Store into the cloudlet. We also did some standard packaging, what we call service VMs. Service is being used really like in the service-oriented computing sense, in the sense that the capabilities in a cloudlet are packaged as VMs that provide a single particular service for a client. And it's a standard packaging. Why? Because we want to be able to provision these cloudlets from a USB drive, from some kind of service VM repository, from the phone itself. And so that's what that refers to. Optimal cloudlet selection. In our architecture, we have made it possible to plug in different algorithms for optimal cloud selection. So for example, if I have not only one cloudlet, but several available cloudlets to me, I should offload to the less loaded cloudlet, or I should offload to the cloudlet that's closest to me, or I should offload, but then I can plug in different algorithms to make that decision. We also added a cloudlet management component, which is actually what those people that attended the demo, what they saw. Very simple console type of interface to be able to quickly see what is running on the cloudlet. And also cloudlet handoff and migration. This is something that actually is I would say it's in progress. It's not fully tested yet. I would say it's in progress. But the idea is that if I have more than one cloudlet, can I both manually and opportunistically migrate some of my capabilities from one cloudlet to another, because one is very loaded, because I am in proximity of this cloudlet, but I'm moving away from it, and I'm going to another cloudlet that is over there. So, and we, like Ned said, we've been very lucky in this area because we've gotten a lot of publications accepted as well as a book chapter. So where are we going? And I know I'm over my time. I know you're like, so oh my gosh. Okay, there's a box there that says something. Where are we going in FY15? So in FY15, what we're going to work on is, one is establishing trusted identities in disconnected tactical environments. So a lot of when we demo our cloudlet capabilities, a lot of people say, okay, but what about security? I'm like, well, security is in there. But I understand, if I'm out in the field and I discover a cloudlet, I want to be able to know it's a friendly cloudlet. And the same way, the cloudlet wants to know that you really are somebody that I should be talking to. So what we're working is, we've partnered with collaborators from CERT to work on this particular task, which is trying to establish that first piece of security, which is trust. The second one there, it actually should say, Soumya, what is the name for, I can't even see it on here. What is the name of this task? The second one? The one you can't see?
Assigning capability scores to social media.
Thank you. Assigning capability scores to social media in real time. And the idea, and then that also stems from the edge analytics work, because when we're using Twitter data, and when people see it, they say, well, but how can I mean, anybody can tweet. How can I really trust that data? And so the idea is to be able in real time to say, to be able to say, yes, you can trust this tweet or this trend that is showing the edge analytics system, and our level of confidence is 70% or 80% or 90%. The third one is fusion of social and physical sensor data. The idea is to be able to, again, use the edge analytics as an infrastructure, but to be able to integrate it with other data streams to create a better situational awareness picture. And finally, GAMS, the Group Autonomy for Mobile Systems, is transitioning to the FY15 Lens Elastic and the FY15 Line Dart projects that are very, very related to autonomy and collaboration.